This is section 7.1, the extend and the apply questions. We start here at question number 17, which is an apply question. It says find an expression for each area of the figure. So for this shape here, and this shape here, all three are different shapes. They're all a rectangle, which if we're finding the area, we're going to use this formula. If we're using the formulas, we're going to use base times height divided by 2 for a triangle. And for a square, our formula for a square is simply side squared. So for all three, we're going to start with formulas, and then what we're going to do is we're going to apply the data that we have, and we're going to simplify it to get an expression for the area. So for the first one, area equals length times width, so we're going to have 11, oh, that's not an 11, we're going to have 11x multiplied by the width, which is 3x. If we use associative property, we multiply our numbers together, or our coefficients, to get 33. Multiply our variables together, we get x squared. So the area of that particular one will be 33x squared. That's an easy one. In the second one, area equals base times height divided by 2. The base is 10p multiplied by the height, which is 4p divided by 2. Multiply the top parts, 10p times 4p. 10 times 4 is 40. P times p is p squared. And finally, half of p squared will be 20p squared, which will be the representative expression for the area of that triangle. And finally, area of a squared is side squared. Since the side is 1/2 w. Now, before I go any further, I want to make sure that we understand this. Half of w is the same thing as half of w, which is the same thing as taking w and dividing by 2. All three of these are the exact same thing. This particular case, it's starting with this, but you could have written it like this if you wanted, or you could have written it like this. Half of w is still going to be that. And if we're going to square that, what we're really doing is we're going to take half of w and multiply it by half of w. Now again, given the 3 here, I'm actually going to use this one right here for this one. So we could say or half of w squared. And the reason why we're going to use it that way is because it makes much more sense when I show you that half of w squared means half of w times half of w. Multiply the numerators, you get w squared. Multiply the denominators, you get 4. That is your answer. But if I reinterpret that, I could also say that's a quarter of w squared, or a quarter of w squared. Question 18 says, what's the missing dimension for each figure? Here we have, just like we did in the last questions, we have an area model where the area is given and the side length is given, but the missing side. So if we use the standard formula, the area of a rectangle divided by its side, or the side we know, or side 1, will equal the side we don't know, or in this case, side subscript 2. The area of the rectangle in A is 15x squared, divided by the side we know, which is 5x. Another way you could have done this at 5x times what is 15x squared. We would have known just through mental math that that's 3x is 5x times 3x. But if we divide it, we're thinking about dividing the coefficients multiplied by dividing the variables, because if we multiply 15 by x squared, we get 15x squared. If we multiply 5 by x, we get 5x. So therefore, this would have reduced down to 3 over 1, or over here, if I was doing it this way, 3 over 1. And x squared divided by x squared divided by x will equal x to the 1, or just x. And therefore, the missing side length is still 3x. If we look at our second one, our formula for this one's going to be a little bit trickier. Here we have base times height divided by 2, or, the area equals base times height divided by 2. So the area equals 3.3 w squared equals the base of, we're just going to make the base, we'll make it b, multiplied by 1.1 w divided by 2. So if we think about this algebraically, and I want to isolate for the b, for the base, the first thing I want to do is I want to multiply both sides by 2. Keeping in mind the algebraic expression, whenever you do one side, if I double this side and I double this side, I maintain equality. That's a fairly important one. But instead of having base times 1.1 w divided by 2, multiplying it by 2 is going to leave me with base multiplied by 1.1 w. That's what's going to be left over there. And over here, if I double 3.3 w squared, I end up with 6.6 w squared. Remember, our goal is to isolate b. So if I'm multiplying b by 1.1 w, if I divide it by 1.1 w, I isolate the variable for the base. But I have to divide this side by 1.1 w. And 6.6 divided by 1.1 is 6. W squared divided by w is w. And therefore, the base will be 6w. Question 19, the area of a rectangle is 72d squared, and its length is 20d. So I'm going to draw this first. I'm just going to put in my area equals 72d squared. I'll put my side length as being 20d, and I'll put this as being the missing side length. I could use x or I could just use a square. It doesn't really matter. What is an expression for its width? Actually, it's probably best we use w for its width, since we're actually looking for the width. So it's 20d multiplied by the width will equal 72d squared. Isolating using variables, I'm going to divide both sides by 20d. And I'm going to end up with the width is equal to 72d squared divided by 20d. 72 divided by 20, 72 should be 3.6 divided by 20 equals 3.6. And d squared divided by d is just d. So we end up with the width is going to equal 3.3 or 3.6 d squared. 3.6 d. Sorry, not d squared, just d. Brain not working. Question 20 says Claire wants to build a patio outside her cafe. The rectangular space outside of Claire's cafe is 3 times as long as it is wide. The area is 48 meters squared, so the area equals 48 meters squared. Claire would like to build a patio with dimensions of 3.5 by 12.5 in the space. Will it fit? So if we think about the area here as being 48 meters squared, that's the entire space. But she just wants to build a patio that will be 3 times as long. So if we think about this patio, let's just make a patio here. If this is x, the length is x, or the width is x, then she wants to make the length 3 times that, okay? And it has to fit within 48 meters squared. So if we think about this, if this is what she wants to build, then the length area of this particular patio will have to equal the width times the length, or 3x times x, doesn't matter. If we think about this, the area of that patio has to be 3x squared in terms of algebraic expressions. And that has to be 3x squared has to be equal to 48 meters squared. 48 meters squared. If we think about this expression, that this has to be equal, it can't be greater than, actually it should be an inequality, but we'll leave it as an equality. If I divide both sides by 3, then x squared will have to equal 48 divided by 3. 48 divided by 3, if you grab your calculator, 48 divided by 3 will equal 16. And therefore x, when I square root both sides, x will be equal to 4, right? X will be equal to 4. So if this is equal to 4, then this will be equal to 3 times that, which would be 12. So 4 times 12, will it fit into this dimensions right here? Well, this will, the length will, however, this won't, because she wants it, or sorry, backwards. I got that backwards. This will, because it's 3.5 this way, 3.5 meters, but this won't because it's 12 and she needs 12.5. So will it fit? No, it's not long enough. And that question is incredibly difficult. And if you didn't get it, don't worry about it. Just skip it, purge it from your brain, because I don't even know if I interpreted it correctly to begin with. Question 21 says the diagram shows that x is the radius of the large circle and the diameter of the small circle. Write the ratio of the area of the large circle to the area of the small circle and simplify the expression. This is a tricky one. So we're going to put large to small in terms of ratio. And if you wanted to, you could go large to small also as your ratio. If you wanted to set it up like that, you could. But let's just look at it like this. So the large circle, the area of a large is going to be pi times r squared. And the area of the small circle, we'll just deal with this first, will be 3.14. And since the large circle's radius is x, we're going to put x squared. That is going to be a expression that represents the area of the large circle. If we think about the small circle here, if this is the radius of the large circle, this distance here is the same thing as this, which is really half of x. So our formula is pi r squared. The radius is going to be half of x, so it's going to be 3.14 multiplied by half of x squared, right? Because if the radius of the large circle is x, then the radius of the small circle will be half of that, and therefore we're going to use this expression half of x squared. If I simplify this part, I'm going to go 3.14 multiplied by x squared multiplied by x squared, or sorry, half of x multiplied by half of x, which is going to be a quarter of x. And this is where it gets a little bit tricky. Sorry, x squared over a 4. If we think about 3.14 as the coefficient, we can treat it as over 1. And therefore, multiplying the numerators will get me 3.14x squared. Multiplying the denominators, I get 4. Now, that is an expression that represents the small circle. This is an expression that represents the area of the large circle. If I compare the two, I realize that since this is a quarter of this one, right? Therefore, this one right here is 4 times as large as this one, if they're ratio. And therefore, the area of the large to the area of the small is a ratio of 4 to 1, meaning the area of the large circle is 4 times bigger than the area of the small circle. (22) A circle is inscribed in the square as shown. The radius here is r. In terms of the radius r, determine each of the following. What is the area of the square to the area of the circle? So if we think about this distance here as being r, this distance here is r, this distance here is r, and therefore this distance here is equal to that, which is 2r. So therefore the square itself, if I think about what the length is, it's going to be 2 radius and 2 radius. So the area of a square is side squared, or 2r squared, or 2r times 2r, which would mean the area of this square is going to be 4r squared. Area of the square equals 4r squared. Done. If we think about the circle is going to be, area of a square is pi r squared, which of course is just going to be 3.1 times r squared, because the radius is the radius of the square. So the ratio of square to circle will be 4 to 3.14, right? The ratio, or 4r squared to 3.14 r squared. And finally, the last one, B, the perimeter of the square to the circumference of the circle. Perimeter of the square will be 2r plus 2r plus 2r plus 2r, or the perimeter of the square will be 4 multiplied by the side length, which is 2r. If we go back to chapter 5, actually, no, sorry, monomial 7.1 will be 4 multiplied by 2r, which is 8r. And the circumference of a circle, oh, sorry, this is length times width. Or no, sorry, 4s, not length times width, we're doing perimeter. And the perimeter of a circle is pi d is the formula, or 3.14. If the diameter is, or the radius is r, then the diameter of that circle is 2r, which will be 6.28 r. And therefore your ratio of your perimeter of a square will be 8 to 6.28. Question 23 says, Jonese, and Elisa are taking 2 tourists on a trip to photograph caribou. Excuse me. The visitors will be traveling by dog sled. The dog sled's length is 4 times as long as it is wide. The sled has a rectangular base of 3.2 meters squared. The equipment to be loaded on the sled measures 0.8 meters by 3.5 meters long. Will the equipment fit? So this is exactly the same as the patio question, except we're going to draw the sled this time. And if it's 4 times as long, if this is width, then the length of this will actually be 4 times whatever that length is, right? That's the area of that sled. And if the sled has a rectangular base with this area equals 3.2 square meters, then therefore 4w multiplied by w equals 3.2, or sorry, yeah, equals 3.2. and 4w squared equals 3.2. Divide both sides by 4. You get w squared equals 3.2 divided by 4 is 8, 0.8. And when I square root both sides, w squared 0.8 square root, excuse me, is 0.89. So if I square root this side and square root this side, I get w equals approximately 0.89 meters. So the width is 0.9 meters. If the equipment that has to go on is 0.8 and the width is 0.89, it will fit on the width of it. And if I think about how long that is, so 4 multiplied by 0.89, just to double check, if I take 0.89 and multiply it by 4, I get 3.57. And since it's only 3.5 meters long, it will just hang out over the edge, and therefore it won't fit onto the sled. It'll hang over just a little bit, which is not going to be possible because otherwise everything's going to fall off. The dogs are going to do whatever. Won't work. Question 24, a rectangular prism has a volume in cubic centimeters expressed as a monomial 60xy. The length and the width of the prism in centimeters are 4x and 3y respectively. Determine the height. So remember, volume of a rectangular prism equals the area of the base multiplied by the height of the prism, or since the base of a rectangular prism is rectangle, length times width multiplied by height. The base, the length and width are 4x multiplied by 3y multiplied by the height, which we don't know. But this is going to be equal to the volume, which is given to us as being 60xy. So 60xy, the volume, which is given, will equal the length times the width, which is actually 12xy multiplied by the height, which we don't know. I want to get rid of that. I want to isolate for h. So I'm going to divide both sides by 12xy and divide this side by 12xy. The height of the particular prism will equal, well, 60 divided by 12 is 5. Xy divided by xy is nothing. So therefore, the height of this prism will be 5. The next one says write an expression for the surface area of the rectangular prism. Let's draw this again. So here we have our length was given to us as being 4x. Our width was being 3y, and the height we just figured out was 5. Right? So there is our prism drawn. If we're doing surface area of this one, I'll take my highlighter here, my yellow highlighter. Remember, there's a front and a back for surface area. That front rectangle is actually the measurements of, for area, is 4x multiplied by 5, which will be 20x as surface at the front. And again, there's a back, so we're going to put the front and the back is going to be 20x for the front, and then we're going to double it because there's a front and a back. Plus, we're going to do the left and right. We'll do that in green here. If we think about what this green one is, it's going to be length, which is 3y multiplied by 5, which will mean that that left and right, there's two of them. The right one that we've just drawn there is going to be 15y. But because there's a left and a right, we're going to double it. That's your left and right. And we're going to do your top and bottom, which we'll do in a light blue here. The length is 4x times the width, which is 4, so it's going to be 4x multiplied by 3y, which will be 12xy as the area. So plus 12xy, which is the top. But there's also a bottom, so we're going to multiply that by 2. That's going to be for your top and bottom. Work this out using BEDMAS. We're going to multiply it. We get 40x for the surface area of the front and back, plus 30y, which is the area of the left and right, plus 24xy, which is the area of the top and bottom. And since none of those are like terms, we're going to keep it as a trinomial. And finally, the surface area of that rectangular prism will be 40x plus 30y plus 24xy. How is determining 9n divided by 3n squared similar to and different from 9n squared divided by n, 3n? Well, in terms of similarity, if we think about how we're going to solve this, if we think of it as the product of fractions, it's going to be the coefficients are going to be that, but our variables are going to be this for the first one. And we think about the second one, we're still going to have the same coefficients being divided by each other, but the place in which these are done. So when I simplify this, I'm going to get 3 over 1, and I'm going to get 3 over 1 both times. But here, I'm going to get 1 over n, and here, I'm going to get n over 1. So when I work this out, my answer is going to be 3 times 1 over 1 times n, which is going to end up being 3 divided by the number n. And when I work this one out, I'm going to get 3 times n over 1 times 1, which is simply 3n. Are they different? Absolutely. But what's similar is the coefficients are going to be similar, but the variables are going to be different. Question 26 says A and B represent monomials. When A is multiplied by B, or A times B, the result is A. When A is divided by B, the result is A. What is the monomial B? Well, this is interesting. This is actually quite an easy question. So what does B have to be? So what number, whatever A is, when I multiply it by this B right here, I always end up with itself. So therefore, we know the only thing you can multiply by, A by, in order to get itself is the number 1. There's no other number that multiplies by itself to get itself. And the same thing is true with what number do you divide by a number and get itself? The answer is 1. So therefore, B must be number 1. And finally, 27. It says a contractor needs to order glass for a window. The window, right here, is in the shape of an isosceles triangle. An isosceles triangle means that this side and this side are equal in length, and the base can be whatever measurement. It could be the same, otherwise it would be equilateral. It says the height of the window is 2.5 times the base. So if this base is B, then the height of the window will be 2.5 times that, or 2.5b, right? 2.5 times as high as the base. Determine an expression for the area of the window in terms of the width of the base. So here we have our formula, area equals base times height divided by 2, or the base is b multiplied by the height, which is 2.5b divided by 2. Multiply the numerators, I get 2.5b squared over 2, or if I divide the coefficient 2.5 by 2, I end up with 1.25 b squared as the expression that represents the area. B says if the width of the base must be 85 centimeters, what is the largest window the contractor can use? So if a base is 85 centimeters, so if I substitute 85 centimeters into my base, so 1.25 multiplied by 85 centimeters of the base squared, right? The base can be 85 centimeters. Must be 85 centimeters. So I put it in there, 85 centimeters squared. I can use that, I guess, square it, is 7,225. So 1.25 multiplied by 7,225. That's a 5, not an 8. Multiply that number by 1.25, and you end up with the largest it can be is 9,031.25 square centimeters of area. That's the largest it can be if the base has to be 85 centimeters.